Good morning, my dear friends. Now we shall begin with some of the problems now. Okay, I will quickly read this problem now. A concrete beam with section 100 by 250 mm spanning over 8 meter is trussed with a straight cable carrying an effective pre-stress of 250 kilonewton. Okay, the pre-stress is 250 kilonewton. Located at an eccentricity of 40 mm below CGC. Okay, if the beam supports a superimposed load of 1200 Newton per meter, then calculate. Okay, all those things we'll see it later. So now what and all he has given here is now, okay, there is a beam of span, I think 8 meter. Okay, 8 meter is the span of the beam. Okay, it carries a UDL of 1200 Newton per meter, and it has got a straight cable, okay, which is laid at an eccentricity of 40 mm. E is equal to 40 mm, and the cross section is now 100 mm by 250 mm. Okay, and since depth is 250 mm, I think yt you can write and yb also you can write. Okay, so it is 125 is yt and yb is also now 125. Okay, so you can easily write it now. So now what and all he has asked, let us try to see now. A, calculate the stress distribution at midsection. This is the first thing he has asked. So first of all, we'll try to find out these stresses now. Okay, stress at midspan section. So but now, as usual, we can find out your area. Area is 100 into 250, as you know. Okay, so you will get this answer. Moment of inertia can also be calculated. It is BD cube by 12. Okay, and YT, as I said, YT is plus 125. Am I right? Because it is above CGC. YB is minus 125 because it is below CGC. And eccentricity, since your CGS, in the sense steel is below CGC, okay, eccentricity is also now minus. It is minus 40. Okay, so now we'll try to calculate now, first of all, the dead load UDL, WD. Okay, WD can be now easily calculated. It is this cross-sectional area, 0.1 meter into 0.25 meter. Am I right? 0.1 meter into 0.25 meter into 1 meter along the span of the beam. Along the span of the beam. Okay, this will give me the volume into density of your concrete will give me your dead load UDL 625 Newton per meter. Okay, so now once you know this WD, I think you can easily calculate the dead load moment MD. It is a WDL square by 8. Okay, so WD I know, span is 8 meter divided by 8. Okay, so it will give me so much. Also, he has given me the live load UDL WL, but live load he says that it is 1200 Newton per meter. Am I right? Live load is 1200 Newton per meter. So now you can easily calculate the live load moment also now. ML is equal to WL L square by 8. WL you know, okay, span you know, divided by 8. So ML also works out to be so much. Okay, also now he has given me the effective pre-stress F as 250 kilonewton, or it is 25000 newtons. Okay, so now we shall start finding out the stress distribution at its span now. Okay, so I will try to find out now top fiber stress Ft. Top fiber stress Ft is given by F by A plus or minus Fe Yt by I plus or minus Md Yt by I plus or minus Ml Yt by I. Am I right or not, sir? So now fill up all the values. F you know, A you know, plus Fin you know, eccentricity is minus 40 as you know, Yt is plus 125 and I value also you know. Okay, similarly Md you know, Md just now you have calculated, it is so much. Md value you know, Yt value is now plus 125 divided by I. Okay, and similarly Ml also you know, it is so much. Yt is again plus 125 divided by I. So now it will give me the resultant top fiber stress as plus 14.42 Newton per mm square. So now this plus sign indicates that it is compression. Okay, this is how you can find out the top fiber stress Ft. But now we'll try to find out the bottom fiber stress Fb. I think the same equation, only change is now here it will become Yb, Yb, Yb. Am I right now? So now if at all I want to find out FB, the bottom fiber stress, I think you can easily write the equation. Okay, bottom fiber stress FB is now F by A plus or minus FE YB by I plus or minus MD YB by I plus or minus ML YB by I. Am I right? So now all the values you know, the only change is now YB is now minus 125 because it is below CGC. So if you fill all the values, you will get the stress at the bottom as plus 5.58. Baba, plus indicates that it is again compression, and if you want to draw the stress distribution diagram, it will be something like this. Top fiber is now 14.42 and bottom fiber stress is now 5.58. Okay, this is one thing he has asked you, so you have already found it out. So but now second thing what he says is now B. I will read now. B, what he says, find the magnitude of pre-stressing force with an eccentricity of 40 mm to nullify the stress at the bottom of midspan due to the total loads. See now, what he says is now, 1 minute. See now, in the earlier case, you have got the stress distribution diagram something like this. Bottom fiber stress is 5.58 as you know. So now he says to nullify the bottom fiber stress, in the sense he wants the bottom fiber stress to be 0. If at all this bottom fiber stress is to be 0, how much pre-stressing force he has to apply? How much pre-stressing force he has to apply? Okay, so now we'll try to find it out. Now given that eccentricity is minus 40, so now he wants the bottom fiber stress to be 0. Am I right? So now I have to analyze the bottom fiber stress FB. Okay, for this FB I am going to write the equation. It is F by A plus or minus FEYB by I plus or minus MDYB by I plus or minus MLYB by I. Am I right now? This equation. Now FB should be equal to 0. So I will equate this FB to 0. Now the only unknown is F. F is unknown. Keep it as it is. Area you know. Everything is known to you. Am I right? Fill up the values and the only unknown F can be now easily calculated. F is 178.8 kilonewton. In the sense, if you apply a pre-stress of 178.8 kilonewton, then this bottom fiber stress becomes 0. Okay, and now the third thing what he asks you is now, okay, again find out this pre-stressing force F when eccentricity is 0 to nullify the bottom fiber stress. In the sense, again to make this bottom fiber stress 0, and when eccentricity is 0, Baba, then find out your F. So now since eccentricity is 0, E is equal to 0 now. Okay, again he wants the bottom fiber stress FB should be equal to now 0. So now I'm going to write the equation for this FB. Okay, and I'm equating this FB to 0. Am I right now? So now here the only change is now E is 0 because he wants eccentricity should be 0. So E is 0. So everything can be now easily filled up. So here the only unknown is F. So F can be now easily found. Okay, so F requires, in sense F required is now 350 kilonewton. Am I right, sir? Now, so now here you can see the difference. Baba, when the eccentricity is 0, to make this bottom fiber stress to 0, I need a pre-stressing force of 350 kilonewton. Whereas when the eccentricity is 40 mm, then I need only a pre-stressing force of 178 kilonewton. In the sense, just imagine, my dear friends, from this problem, what I will come to know, eccentricity plays an important role. As you go on increasing the eccentricity, okay sir, now your pre-stressing force required is less. Is it right or not now? Okay, thank you very much.